All right, welcome back. This week we are continuing with our trig functions, talking about those relationships between sides and angles of triangles, especially right triangles. Last week we talked about trig ratios and inverse trig functions, so we're going to go over a couple of problems those today so you get a couple extra examples, and then we're going to continue forward with how sides are related. So if we look at our trig ratios, this was our fractions that we are looking for. If I ask you for trig ratios, I'm looking for a fraction as your answer. I'm going to start by writing up SOHCAHTOA. Hopefully that is ingrained in your memory at this point. SOHCAHTOA I still write on everything, so I can always have that to reference when I am looking for trig ratios, inverse trig functions. Anytime trig is related, that's talking about sine, cosine, and tangent. So this says SOHCAHTOA, meaning sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. Those are those relationships that we have together. So using those, if we're looking for a trig ratio, we're looking for a fraction, we want to look at the sine of theta. I'm going to start by labeling my picture. So across from my theta, I have my opposite leg, I have my adjacent leg, that one right next to it, and then our hypotenuse, the longest side, across from our 90-degree angle. So if we're looking for the sine of theta, sine stands for opposite and hypotenuse. So I look at my opposite is 45 and my hypotenuse is 53. So we have 45 over 53. Then if we're looking at cosine of theta, our cosine is our adjacent over hypotenuse. So my adjacent is 28, hypotenuse 53. And lastly, our tangent of theta. Tangent is our opposite over adjacent. So I look at my opposite of 45, adjacent 28. And those are our ratios. Trig ratios, we just want those fractions. Just looking at the relationship between those two sides that sine, cosine, or tangent are asking for. Our inverse trig functions, those are whenever I'm asking for the inverse trig function, or whenever you use an inverse trig function, what you're trying to find is the missing angle measures. So anytime I'm asking for an angle measure, you're going to have to use an inverse trig function. So in this case, we're looking for finding the measure of angle theta. So if theta is right here, I'm going to label my triangle like we always start with. I have my opposite, my adjacent, and my hypotenuse. And if you look at this, I don't know what the opposite is. I only know my adjacent and my hypotenuse. So instead of doing all three trig functions, I only have the possibility of using one. So which of our trig functions uses adjacent and hypotenuse? Great question. I look through my SOHCAHTOA and I find, all right, here are my adjacent hypotenuse. They go together with cosine, so I'm going to have to use cosine. So I know my cosine of theta, I need to do adjacent over hypotenuse. I look here, my adjacent 77, hypotenuse is 85. So I have this ratio. But we're actually looking for the measure of the angle. So we need to figure out what is theta. And to find that out, we need to get theta by itself. So to undo this cosine, I'm going to use the inverse function, cosine of -1. That cosine theta gets rid of that. And what I do to one side, I have to do to the other. So I'm left with theta equals the cosine inverse of 77 over 85. And if I type that in my calculator, again, make sure you're in degree mode, you end up with 25.1 degrees. And again, I rounded that to the nearest tenth, that first one. So that's your review for this week. Make sure you study that up, and we're going to start something new in the next video.